I'm in Berlin at Art Photonics. The Optica corporate member specializes in mid-infrared fiber from 2 to 14 micrometers. And the reason why I'm here is because I've been seeing for many years that Art Photonics is bringing new applications and new technologies to the mid-infrared industry. I'm here with Alexey. Alexey, what's new at Art Photonics?
So we are manufacturing fiber optic probes, so for reflection, fluorescence, Raman, ATIR, transflection, and transmission. We will announce some new probes in the next year, and now we prepare a short demo of probes in our lab, and I give the microphone to Alexander.
Here we have two different probes. One is transflectance probe, where we have silica fibers for near-infrared region, and the light goes through the sample, and we see their absorption spectra. Yes, but here we see how this absorption spectra is changing during the dissolution of cell media. Yes, so here some peaks go up, some peaks go down. Yes, and we can build some plots, dependencies, so we can see, depending on the temperature, depending on other parameters, how fast is our process. Yes, and here is for near-infrared. Another probe is for mid-infrared region, is using ATR technique, attenuated total reflectance. So light doesn't go through the sample, but it only touches it. And here on this spectra in mid-infrared range, we see, so this range is more informative. It has fundamental vibrations. Yes, so it can be used to more precisely see what is going on during your process. So sometimes customers ask us to make specific probes to fit to their applications, and of course we can do that. We adapt the geometry of the probes, we adapt the path lengths, we adapt the materials and other parameters. We can adapt whatever you want, of course, considering physical limitations.
So Art Photonics provide accessories for well-known spectrometer manufacturers as Bruker, Thermo, ABB, and so on. These coupling units make it available to use our fiber optic probes with the benchtop spectrometers. And Alexander will show us how to use the coupling unit inside the Bruker Alpha 2 spectrometer.
So you have a benchtop spectrometer. We manufacture pre-aligned fiber coupler. So you have a fiber probe, you just simply put the SMA or other connectors with it. Fiber probe is connected. Now we are ready to make measurements. This fiber coupler is delivered with a reference cable, so customer can also check their fiber coupling efficiency, and yeah, it's ready to make measurements, and we can get nice spectra for the mid-infrared range, and we can see the fingerprint vibrations.
Fiber probes can be used in any branch of chemical industry: petrochemical, pharma, polymer extrusions, and even for cryogenic applications, or so high temperature as 250 degrees like these probes, or even 300 degrees like silica fiber probes.
For me, it is fantastic to be here in Berlin at Art Photonics and being able to witness mid-infrared fiber used for process monitoring in front of me. We go from 2 micrometer to 14 micrometer, and we can measure the transmittance, the reflectance, the fingerprint, the absorption fingerprint of any compound real time. And I understand that one of the biggest recent breakthroughs is your 200 micrometer fiber for path coupling quantum cascade lasers.
Yes, so we are manufacturing now 200 micron fibers from polycrystalline materials. So, and they are transparent from 4 to 18 microns.
The fact that they are so thin, only 200 micrometers, what's the advantage?
So it's very flexible, and same time you can bend it well, and yes, you can have a small spot after the fiber
Later today I'm going to visit a company called Quantium. They manufacture QCLs. With these fibers you can actually make fiber bundles and pigtailing many QCL at once.
Yes, sure. You can make a bundle from let's say 7 fibers together and couple 7 different light sources like quantum cascade lasers.
For all the Optica corporate members, we're gonna witness firsthand how these fibers, 200 micrometer mid-infrared fibers, are manufactured. Alexey, let's watch it. Please follow us. I'm here with Valentyn. Valentyn, thank you very much for having us. What's this?
So it's extrusion, yes, so extrusion of our mid-infrared fiber. You see here our polycrystalline infrared fiber. So here is the oven and this big machine, press machine. So we make the extrusion process from this before. Actually we do from this one. So we have here full cycle process. In another building we have the crystal growing process. Here we make the preforms, yeah, so also in this room. And after this small preform we have here, and with the method of extrusion we press the fiber, and you can see it here. So with a high temperature, with a high pressure, we receive this kind of miracle. So here you can see the examples of our mid-infrared fibers. Here you can see the fiber with 200 microns outer diameter. Yeah, so usually we put it here. Yeah, so it's one of the smallest of our fibers. So it's one of the examples. Here you can see, for example, the fiber with the outer diameter was 1000 microns.
One of the biggest challenges of polycrystalline fiber is that they cannot be spliced, correct?
Yes, sure, because it's not a glass material.
I think you are all gonna witness how we can manufacture mid-infrared fiber, polycrystalline fiber, only possible with the extrusion process. And now I think it's time for me to go. Thank you very much for having me here. It was great to be visiting Art Photonics facilities. What is your preferred future?
We are hoping that the industry will be more aware about Art Photonics products. We manufacture very robust polycrystalline fibers and fiber optic probes based on it. We produce even products with silica and other mid-infrared fibers. So any customers, you are welcome.
For many years, probes based on mid-infrared fiber have been seen by the industry as a nice solution, but maybe not yet robust enough. For many years, Art Photonics have been producing very robust fiber-based solutions. How do we communicate to the industry that mid-infrared fiber probes are ready to solve problems today?
So we are open for most of manufacturers of spectrometer to let's say to visit them with our demo probes, to make webinars with customers, and you are welcome to visit our webpage where you can find the technical information about our probes and the properties. So,
Alexey, I really have to go. I need to visit Diamond Tech. Thank you very much for having me. It is time to go. I continue in Berlin. I love this city. It's time for me to go to Diamond Tech.